Today we are going to look at another day of section 3.7. So that means we're applying theorems relating the angle measures and the side lengths of triangles. Let's take a look at this algebra problem. We want to solve for both x and y. So if we look at the picture, we have a triangle and I see that there are two sides marked congruent. So remember, that makes it an isosceles triangle, and if two sides are congruent, that means that the angles that are directly across from them are also congruent. So that means that this 52-degree angle and this angle, which is represented as 2x minus 8, are congruent. And so I'm going to be able to use that information to solve for x. Congruent means equals, so I'm going to set those two equal to each other. I'm going to add the 8. That gives me 2x to equal 60. I'm going to divide by 2. And so one of my answers, x equals 30. So I have x, now I want to solve for y. Y is representing that third angle of our triangle. And remember, 3 angles of a triangle add up to 180. So to find the measure of angle y, I know that I just have to subtract 52, not once, but twice. Because remember, if I know this angle is 52, that means that 2x minus 8 is also 52. So there are two 52-degree angles. I'm going to subtract both of those from 180, and that's going to give me what y is. So 180 minus 52 tells us that y is going to equal 76. Let's take a look at this proof. So go ahead and draw a picture. And once you have that picture, let's go ahead and write down our first given. I know that angle D is congruent to angle E. And I'm going to mark that in my picture. All right. I think I'm going to jump to I want to look at what I'm trying to prove first, though. So let's look at this. I want to try to prove that the triangle CDA, so I'm going to highlight that. CDA is this triangle right here. I want to prove that that is congruent to the triangle of CEB, which is this triangle over here. All right, so those are the two triangles. Notice that I already have now one set of angles that are marked inside of both of those to get me closer to proving the triangle's congruent. I am going to also look at the fact that there are a lot of triangles in this picture, but the very biggest triangle is the triangle CDE. And with us just being told that angle D and angle E are congruent, hopefully we can look at that and say, hey, if those two angles are congruent in this one really big triangle, we have a theorem that I can expand on. So I actually know that the segment CD is congruent to the segment CE because of our theorem that if I'm starting with two angles congruent in my triangle, then I know that the two sides directly across from them are congruent. And notice that that's helpful information because those are sides that are also a part of the triangles I'm trying to prove congruent. All right, I'm going to move on to my next given. I am told that point A is the midpoint of the segment DB. So because I have a vocab word, I'm going to expand on that. If A is the midpoint of DB, I know that a midpoint divides a segment into two congruent segments. So looking at the problem, it looks like segment DA is going to be congruent to the segment BA. And like we said, if a point is a midpoint, it divides a segment into two congruent segments. So now I get to mark that those two segments are congruent. All right, we have one more given. So I get to say that point B is the midpoint of the segment AE. And so just like our third step with that midpoint, I know that I get to expand on it. So if I'm talking about the segment AE, well, that means that we are going to be able to say that the segment of AB is congruent to the segment of EB. And our reason is the same as step 4. So notice that AB is already marked with 2 tick marks. That means I get to mark BE or EB with that same set of tick marks. So now if I look at the bottom of that really big triangle, I have 3 segments that are congruent. So notice that I have to state, because if I look at my proof, notice how BA or AB is seen twice. Okay, that's linking those other 2 segments together. So that takes us back to a chapter 2 concept. If something is being linked together, I can say that the segment DA is congruent to the segment EB. And that linkage there is because of the transitive property. But now that I have that stated, I do look at my triangles and I see 3 things that are marked in each of those triangles. So that's going to give me enough information. I can prove that the triangle CDA is congruent to the triangle of CEB. And this is because of side angle side. So my first set of congruent sides came from step number 2, when we were able to say that if the angles were congruent, then the sides directly across from them are congruent. Then I'm looking for the angles. Well, that came from step number 1. My other set of sides came all the way down in step number 7. So there is my proof. Let's take a look at another algebra problem. I want to solve for both x and for y. Notice that in this problem, I can solve for x because I have x's for both of those angles, and I've got a right angle in this triangle as well. And I know that 3 angles of a triangle add up to 180. So I've got a 90-degree angle, and then an x and an x. Those 3 angles have to add to 180. So I'm going to subtract the 90. And if I combine x and x, that gives me 2x. So 2x equals 90. If I divide by 2, that tells me that x is 45. So there's one of my answers. Because those 2 angle x's are there, I mean, x is congruent to itself. So that's why those 2 are congruent. And so then within the picture, if those 2 angles are congruent, that means that those sides directly across from them are congruent. So that's how we're going to solve for y. I know that y plus 15 is going to have to equal 21. And so all I have to do to solve for y is subtract the 15. And so 21 minus 15 tells us that y is going to equal 6. Let's take a look at another proof. So go ahead and sketch the picture because we want to be marking that up. And now I'm going to start writing. So we know our first given, angle BCF, is congruent to angle DCE. That's given. So follow the letters, BCF, that's this angle. That's congruent to DCE. That is that angle. All right. Moving on, I know that the segment CE is congruent to the segment CF. That is given. So CE, that segment. CF, that segment. Moving on, I know that C is the midpoint of the segment BD. Now, because that third given has a vocab word, I need to expand on that. So if I'm given a midpoint, I'm going to be dividing the segment into 2 congruent segments. So it looks like segment BC is going to be congruent to segment DC, because if a point is a midpoint, then it divides the segment into two congruent segments. And then I'm going to mark them. All right, so we want to try to prove that the segment AB is congruent to segment AD. There's a lot of information going on, but I think what I want to start with is I want to figure out what triangles to get congruent. Well, there are actually only 3 triangles in this crazy picture, and only 2 of them are triangles that we can actually see are the same size. So that's this triangle, and that's this triangle. And right now, I don't want you to assume incorrectly. Right now, there is actually only 2 things that are marked, those 2 sides. The angles that were given to us for the first given, those are angles that fall outside of the triangles. Part of the angle's inside, but part of it's outside. Notice that both of those angles overlap in the middle right here. That angle ECF is what's helping create those 2 angles that were given. So because I really want angles that are smaller than the angles given, I'm asking myself, how do I go from something big to something small? Well, that would be subtraction. So I'm going to say that the angle of ECB is congruent to the angle of FCD, and this is through subtraction. So it's the subtraction property. So remember, subtraction means we start big, we end small. So what did I start with? I started with the angle BCF. I'm subtracting that common middle angle of angle ECF. That got me angle ECB. On the other end, I started with the angle of DCE. And once again, I'm subtracting that common angle of angle ECF. When I subtract that common angle, that gave me angle FCD. So that's this angle, and that's this angle. And so now I have 2 triangles that are congruent. So I can say that the triangle of ECB is congruent to the triangle of FCD, and that's because of side angle side. So the first set of sides in the triangle came from step number 2. The angle came from step 5 when we subtracted. And then step number 4 got us our other set of sides. So now that I have congruent triangles, I want to figure out how is that going to help me get to what I really want, which are these two, I want these 2 really big sides right here. So for that, I want to think of our theorem that deals with the big triangle of ABC. If I want to try to prove that those sides are congruent, that means that I need to have angles congruent because that's our relationship. If I have angles congruent, then the sides directly across from them are congruent, which means I need to get angle B and angle C to be congruent. Well, notice that angle B is inside of that triangle we just got congruent. That's not a C, that should be a D. Okay, so that's the big triangle. ABD is the really big triangle. So notice that angle D is that angle inside of that triangle. So I'm going to say that angle B is congruent to angle D, and this is because corresponding parts of congruent triangles are congruent. Okay, that gives me those 2 angles. And so now that I have those 2 angles, I can prove what I want. So I can say that the segment of AB is congruent to the segment AD, and that is because if I start with those angles congruent, then I know that the sides directly across from them are congruent. But that only happens when you're talking about one big triangle. It's not 2 individual triangles, it's one big triangle. All right, let's look at this algebra problem. So I'm going to be marking up my picture, so go ahead and sketch that picture. We know that segment AB is congruent to segment AC, so I'm going to mark those. I know that angle ACB, so follow the letters, ACB is going to be 3x. And if I follow the letters ACD, which is this angle outside of the triangle, is 10x plus 24. We want to find the measure of angle B. Okay, so the two angles that they gave us are two angles that are supplementary. They are forming a straight angle. So I'm going to solve for x by adding those two angles and setting it equal to 180. So we'll have 13x plus 24 equals 180. I'm going to subtract 24. That gives us 13x to equal 156. And then I'm going to divide by 13. And I'm going to get x to equal 12. Not my final answer, but now that I know what x is, that means I can find the measure of the angle ACB. So the measure of angle ACB is going to be 3 times 12. So that's a 36-degree angle. Now, with them telling us that the side AB is congruent to the side AC, remember, if those two sides are congruent, then I know that the two angles across from them are congruent. So that means we just found angle ACB to be 36, but that's actually congruent to angle B. So we actually then found our answer. Our answer is a 36-degree angle. And that's us applying theorems relating the angle measures and the sides of the triangles.